chain rule. So when we want to find the derivative of a function, we don't always just have x to the power of some number. Sometimes it's a function of x. So we might have something like this, where y equals x plus 2 all squared. And we can't just bring down our power and minus 1 from the power whenever we have a situation like this. In this case, we could first expand our function. So square the first term, double the product of the two terms and square the last term, and then find the derivative of each of these separately to get 2x plus 4. But we can also apply what's called the chain rule. And the chain rule is that if we have y equals some function of x to the power of n, the derivative, well, we can bring the power to the front of the function and minus 1 from the power, but the only difference is we have to multiply by the derivative of the function inside. So let's do it for the example we just had. So at y equals x plus 2 all squared, the derivative. We bring the power down to the front, write our function, minus 1 on the power, and multiply by the derivative of the function inside. And the derivative of this, we've just got two terms here. The derivative of x is just 1, and the derivative of 2 is 0, so we're actually just multiplying by 1 here. So we tidy this up, so that's 2 outside of x plus 2, and we can expand that out, 2x plus 4, and we get the same result as we did when we expanded it out. And you won't always be able to expand it out quickly, so the chain rule will come in handy for that. You can imagine if the power was 8, we wouldn't want to be expanding this out. Let's have a look at some more examples. Y equals x squared plus 4 all to the power of 6, and we want to find the derivative. Well, here's where we're going to need the chain rule. So our derivative, we bring our power to the front, write our function, minus 1 on the power, and we need to multiply by the derivative of the function inside the bracket. So derivative of x squared, well, we'll bring the power to the front, and we minus 1 from the power, so we just get 1, and the derivative of 4 is 0. And that's all we get, and we can just tidy this up by multiplying our 6 with our 2x to give us 12x outside of x squared plus 4 to the power of 5. What about y equals x squared plus x to the power of 5? We want to find the derivative. So dy dx, we'll bring our power to the front, write our function, minus 1 from the power to give us 4, and now we need to multiply by the derivative of our function. Derivative of x squared is going to be 2x, and derivative of x is going to be 1. But it's very important you write everything in a bracket here, especially when you have multiple terms in here for your derivative of the function inside, because everything needs to be multiplied by this derivative. And we can tidy this up a little bit, writing 5 outside of 2x plus 1 outside of x squared plus x all to the power of 4. I usually write my brackets with the lowest power first, but it doesn't matter technically the order you write them, because it doesn't matter when you multiply. Let's have a look at another example. Y equals the square root of x cubed minus 7. Now in calculus, you never really want to deal with roots because they're of no use to us. It's much better dealing with indices. So if you ever get square root or cube root, you want to change it into index notation first. So we can rewrite this as x cubed minus 7 all to the power of a half. And now we can apply the chain rule to find our derivative. So we get dy dx, bring our power to the front to get a half outside of x cubed minus 7, minus 1 from a half gives us minus a half, and times by the derivative of the function inside, so derivative of all of this, derivative of x cubed, bring our power to the front, so we get 3x squared, and derivative of minus 7 is just 0, so that's all we have. We can tidy this up a little bit. Since we have a negative power, we know we've got a fraction, so I'm going to write it without a negative index, and the things we need to write at the top, well, we'll need to write 3x squared at the top, multiplied by 1 to just give us 3x squared, and the 2 and this term will be at the bottom, so we'll get 2, and we want to write it back in surd form, so we'll get 2 root x cubed minus 7 as our final answer for the derivative.